So today we're going to be looking at 5.5. Now, why I didn't put chapter 5.5 in chapter 5 exam is because I don't want you to make a mistake and get 5.5 confused with everything else that we did in 5.1 through 5.4. Okay, because 5.5, we're going to be solving these. Now, in 5.5, we have equations. The other sections, we had what were called expressions. So let's just take a moment to just review the difference between an equation and an expression. So 5.1 through 5.4, these were expressions. And these expressions we could factor. So things like 3x minus 6, right? You could factor that. You could take a 3 out, and that would leave you with 3 times x minus 2. You might have something like x squared minus 49, right? And you could factor that as x plus 7, x minus 7, and so on. Those were expressions, and these do not have an equal sign. And since they don't have an equal sign, we could never actually solve them. Okay? What we're going to be looking at in 5.5 is a little bit different. And again, I separated it from the other sections because in 5.5, we're going to be focusing on equations. And when we talk about equations, see, these have an equal sign. So these are examples of our equations. So we could have x squared minus 36 equals 0. You could have something like x squared plus 4x, say plus 2 equals 0, and so on. Okay, these are equations. These have an equal sign, and they can be solved. So these are going to give us an answer. When we look at these are going to give us a numerical value. And we may have more than one solution as well. We might have several. But we're going to be focusing today on equations out of 5.5. Now, we are going to be using the same techniques that we used throughout chapter 5. But we are going to be taking it one step further. These are equations, so we're actually going to be solving them. Now, how we solve them is we're going to be using what's called zero factor. And zero factor is what we're going to be using to solve these. So what we do is step number 1 is you set to 0. Step number 2 is you factor. And step number 3 is you solve each part equal to 0. So you set it to 0, factor, and you solve. We're going to start off with a very, very easy one. And this one's already going to be set to 0. So let's look at x squared minus 6x equals 0. Now, when we solve these, we look at the highest power. And in this case, what's our highest power? 2. So that tells you how many answers you can have at most. Now, sometimes you may only have one answer, but we could have up to 2. If that power would have been a 3, we could have up to 3 answers. But the highest power dictates how many solutions you can have at most. Now, what we need to first do is set it to 0, which this one is, and now we need to factor. So we're going to factor an x out of here. So we factor that x out. And now we're going to get our 2 solutions. So the parentheses separate the 2 parts. So what 2 parts do we have here? Well, we have the first one. We factored an x out. All right, so that leaves you with an x equals 0 because that came out and it's already equal to 0. What about the other one? Well, the other one is x minus 6 equals 0. So moving that 6 over, you get x equals 6. So we got two solutions. Why did we get two solutions? Because our highest power was squared, and that tells us we can have up to two solutions. Let's try another one. So let's try to solve this one. Well, what is our step-by-step procedure? Set to 0, factor, and then you solve each part equal to 0. So the first thing we'll do is we'll move that 81 over. And that then leaves you with x squared minus 81 equals 0. And we covered these quite extensively, and we can factor, because what can I factor, or how would I factor this down? Well, 81, what do we know about 81? 81 is a perfect square of 9, right? So this would factor into then what? Well, this would factor into x plus 9, x minus 9 equals 0, right? So difference of squares. And for the most part, these are going to be very easy to factor. So what are my two final answers? Well, we have x plus 9 equals 0. So moving that 9 over, we have a negative 9. And x minus 9 equals 0. Moving that 9 over, we get x equals a positive 9. When you go on to college algebra, you can also write it like this. So you could bring it out as two separate solutions, or in college algebra, a lot of times they'll write it as plus or minus 9. So if you see that in college algebra, that just means that you have a 9 and a negative 9 for the solutions. And that's what we use a lot of times in college algebra, is that plus or minus. Let's do another one. Let's look at one that requires us to factor a really easy trinomial. So, how do we handle this one? Well, what do we always need to do first? First thing we need to do is move that 9 over. And now we're going to have to factor. So we're going to factor this. Now, most of the time, they're going to be easy to factor. And this one is pretty simple when we go to factor it. First times the last, there's a 1 here. Okay, so first times the last, that makes it a negative 9. And remember, we took our exam over this last week. We have a negative here. So what does that tell you about the signs? Well, that tells you that one of them is positive and one of them is negative. Sign in the middle is positive. So we need a positive 9 and a negative 1, right? We can jump to our factors. So we have x plus 9, x minus 1, and it equals 0. It has to equal 0. And so now we can get our two solutions. So what are our two solutions? Well, x plus 9 equals 0. We'll move the 9 over. So one solution is x equals a negative 9. The other one is x minus 1 equals 0. Moving our 1 over, x equals then 1. So here are our two solutions, minus 9 and positive 1. Now, do you have a question? Okay. Now, on these were not factored, and we had to factor them. In some cases, they may already be factored. So this one is already factored. And remember, what I mean by factored is we've already got it separated out into parentheses. Now, how many sets of parentheses do we have? Well, we have 3. So that means then that we're going to have probably 3 solutions. It's already set to 0. And so let's find those. So we have x plus 5 equals 0. So x equals a negative 5. There's one of them. 3x minus 7 equals 0. So 3x equals 7. So x equals then 7/3 for the other one. And then our last one is 4x plus 5 equals 0. So 4x equals a negative 5. Divide by your 4. And now we've got x equals a minus 5/4. So here are the 3 solutions. I can also give you something like this. I can give you a quantity squared like this one. Now, what does it mean if it's squared like that? When we have it squared like that, we are not going to FOIL it out. We can, though, rewrite this as 3x plus 4, 3x plus 4, and it's already equal to 0. These are the same. So what does that tell you then? That tells you, since these are the same, you only get one solution. And what would that one solution be? Well, that one solution would be 3x plus 4 equals 0. 3x equals a negative 4. So x equals then a negative 4/3. Now, normally, if we have a square, what does that mean? 2 solutions. And there are 2 of them, but they happen to be what? They happen to be the same. And that can happen. So far, we've seen how to work with some of the simpler cases. Difference of squares. We looked at just factoring a trinomial. We looked at just factoring out a greatest common factor. Now we're going to look at some that are a little bit more challenging. These are going to require us to move things around and factor. You may have to factor as a difference of squares. You may have to factor it as a trinomial. You may have to do factor by grouping. So everything that we've learned is going to go into these questions. So we're going to have to set them to 0 and then factor from there. And I'll just pick a few of these from our textbook to look at. I'm on page 374. And again, I'm just going to randomly grab some. Let's look at question. How about 25? And this is on page 374. And we're going to look at question 25. So when I come up to a question like this one, I first make sure it's set to 0. Has this one been set to 0? Yes. Now then I count the number of terms that I have. Terms are separated by addition and subtraction. I've got 2 terms. And how do we generally handle 2 terms? We either take the greatest common factor out, or we factor as a difference of squares. Right? 27 and 3 are not squares. But what can I factor out of here? Well, we have a 27 and a 3, and it begins with a negative. So these have a negative 3 in common. So we're going to factor that out. And that leaves you then with an x squared, when we factor it out, minus 9, right? So we factored out our greatest common factor. And then what about x squared minus 9? Well, that is a difference of squares. So x plus 3, x minus 3. Is everyone with me so far? So the first thing we did was we said we have two terms. We took out our negative 3. That left us with this. And then we factored it as a difference of squares. Now, there are only going to be two solutions. How do we handle that negative 3 in front? Well, is there an x attached with it? No. So I can actually just get rid of it and not worry about it because there's no x there. And you could do that by dividing. So we got to this point. We factored out our negative 3, so we can divide both sides by 3. That negative 3 there. Now, why did I do that? Now, if you have an x with it, you can't. But if you have a number out in front, you can just divide it out. We factored out that negative 3. And what about these? Well, those can cancel, right? And why we use 0 is 0 divided by any number is what? 0 divided by any number is 0. So that takes care of that minus 3. One thing you need to make sure that you're aware of is that you can never, ever divide by the variable x. You can divide by numbers and reduce things down and get rid of them, but you can never divide by the variable x. We didn't do that. We divided by that number, negative 3. Now, what's my solutions going to be? Well, we have x minus 3 equals 0. So moving that over, we've got x equals 3. And what's our other one? X plus 3 equals 0. So moving that over, well, we've got a negative 3. So we have a positive 3, and we have now a negative 3, and those are your two solutions. The 3 went away because we factored it out, and 0 divided by any number is 0, and it absorbs it. So that's why we work with 0 a lot, because 0 allows you to cancel things out. Okay. So that was one where we used the greatest common factor, so we factored it out. And then once we factored it out, we divided by that 3, and then we factored it as a difference of squares. Okay, let's look at another one. Let's look at question 35. And they're all pretty much the same. And again, this is on page 374. If you don't have your textbook, it's not a problem, because I'll write them up on the screen for you. So we're going to look at 35, which is 2x squared minus 12 minus 4x equals x squared minus that 3x there. Now, what are we doing? Well, we have an equal sign, correct? Whenever we have an equal sign, what do we always set it to? No matter what, we set these to 0. So we're going to move everything to the left-hand side and make it equal to 0. So I'm going to move that x squared over. I'm going to add that 3x over. And we're going to write out what we have left. Sometimes students make a mistake here. Remember, this is a minus 1x squared there. So 2x squared minus x squared. That leaves you with a single x squared. we want to put the x's next. So we have a minus 4x and a positive 3x. That leaves you with a negative x. And then we have a negative 12, and that equals 0. Now we have it set to 0. And what do? We count the number of terms. We have 3 terms. So we're going to take the first times the last. First times the last is a negative 12. And what do we know about our signs here? We know that it is a negative. So that means we have one sign positive, one sign negative. And what's the sign in the middle? Negative. So what are we going to use? We're going to use a negative 4 and a positive 3, right? Because those go together. Multiply to give you a negative 12. Subtract from each other to give you that negative x in the middle. Because of the 1, we can jump directly to our factors. And that is now x minus 4, x plus 3. It has an equal sign. So what are our solutions going to be? X minus 4 equals 0. So one solution is 4. X plus 3 equals 0. So the other solution is negative 3. So here are 2 solutions, positive 4 and negative 3. So this is just an extension of what we've been doing in a previous section. One more of these, and then we'll look at some different ones. So let's look at question 30. I'm picking all the different types. So for question 30, we have 4x squared minus 20x plus 25 equals 0. Now there are a couple of ways of factoring this one out. You could take the 4 times the 25, which would be the 100, come up with your 2 numbers that give you that negative 20 in the middle, and then factor it by grouping. However, there is an easier method to this. Let's look at that 4x squared, and let's look at that 25. Well, what do we know about 4? 4 is a perfect square. And what do we know about 25? Perfect square as well. So 4x squared is going to then break down into 2x and 2x, right? And what about 25? Well, 25 is 5 and 5, right? So there we go. What's the sign in the middle? Sign in the middle is negative, so that's going to come down. And this is what's called a perfect square trinomial. So what comes down is then 2x minus 5, right? Quantity squared. So it's a perfect square trinomial. Now, how many solutions am I going to get? I can get up to 2, but I'm only going to get 1. Why? Because this is actually 2x minus 5, 2x minus 5, and we talked about this earlier today. These are exactly the same, right? So that means we only have one solution. These are the same. And so what's my one solution? It is 2x minus 5 equals 0. 2x equals 5. So x equals then 5 halves. Is everyone okay with how I did that? So that was a perfect square trinomial example. Now, let's look at one where we have to FOIL. So we'll do 2 of these, and then we'll look at one that's a higher power. And then we'll move on to the next section. So how about 38? We'll look here at question 38. And for question 38, we have 3x plus 1 x minus 3 equals 2 plus 3 times x plus 5. And again, we're going to be solving. All the directions are the same, and they're always going to be simply solved. Now, this one's a little bit unique, because what we want is we want only parentheses. And if we move this 3 over, we'd have a 3. We'd have to deal with that 2 as well. Okay, what we're going to have to do is we're going to have to FOIL this out so then we can set it to 0 and then refactor. So we want all the parentheses on one side, and we need to refactor. So what I'm going to do is I'm going to take this. I'm going to take the left-hand side, and I'm going to take it, and I'm going to FOIL it out, because we're going to have to rewrite this and factor it. So take that left-hand side, which is 3x plus 1, x minus 3, and we're going to FOIL it. Remember how we FOIL? First times the first, outside and outside, and last. So first times first is a 3x squared. Outside and outside, it's 3x and a negative 3. So that makes it a minus 9x. Inside is a positive x. Last and last is a negative 3. Putting those together, we now get 3x squared minus 8x minus 9, right? So that is that piece here. Well, what about the other side? What are we going to do with it? Well, we need to get rid of our parentheses so we can refactor it. And we're going to distribute that 3 through. We'll rewrite this as 2 plus 3x, and 3 times 5 is 15. This can be condensed down one more step to 3x plus 17. And I only gave you a couple of them like this, where you have to FOIL. And now what do we do? Okay, now what we do is we look at this as, again, an equation to solve. It's equal. Well, what does it need to be equal to? 0. So we're going to move that 3x over. And we're going to move that 17 over as well. And so move those over. And that gives you now 3x squared minus 11x. Minus, when you put those together, 26, and that equals now 0. There's only a couple of these. These require quite a bit of work. We had to set to 0, we had to factor, a FOIL, and now we've got a factor. So what do we do next? Well, the next thing we look at is we take our first number times our last number. First number times the last number. Nothing else factors out, right? 11 is an oddity because there's everything in common with 3 or 27. So nothing factors. We take our 3 times that negative 26, and that's going to make it a negative 78. This is negative, so that tells you that 1 is positive, one number is negative. And what's the sign in the middle? Negative, so that's negative, and that's positive. And what two numbers are going to work? We need that 78, and we need to subtract them to give me 11. So let's take our 78. It's an even number. Let's try 4. 4 won't go in there, but let's try 3, because 2 is probably not going to work, but we'll try 3. Well, that's 3 and 26. That doesn't give me 11. It's too big. I need to go up higher. So we did 78. Let's try to divide that by 6 now. Okay, 6 and 13. Well, 13 minus 6 is what? 7, but we need what? 11. So what do we know? we know that it has to be now less than 6. So let's try, a 4 won't go in there, 5 won't go in there. We tried a 3. Let's make sure I didn't make a mistake here because we've got 3 times that 26. It's a negative 78. Right? And we tried a 2. Well, we haven't tried a 2 yet, but we could try a 2. 2 and 39 is definitely not going to work. Let's try, we looked at 3. 3 and 26 didn't give me a difference of 11. So how about we do a 4? 4 doesn't work. How about we do a 5? 5 won't go in there. How about we do a 6? 6 and 13. Okay, let's see, what else can we use here? We can use a 9. Won't go in there. How about we use an 8? 8 won't go in there. How about a 12? Won't go in there. How about a, we'll find it here in a minute. 16 won't. How about we look at a 78? Let's look at a 18. Won't work. Let's make sure we did it all correctly. Let me double check things and make sure we didn't make a mistake. Make sure I copied it down right because it should factor nicely. It's so easy to make a mistake here. Everything looks right. And let's check our foiling. 3x times x, that's a 3x squared. 3 times a negative 3, that makes it a negative 9. X there. Inside we have a positive x. Negative 3 here. Oh, I see the mistake. This should not be, and it's easy to do. I got in a little bit of a hurry because when I wrote this down, this should be a negative what? My mistake here. That's why it wouldn't factor. That should be a negative 3, shouldn't it? That was my mistake. It happens. Okay, so this should be a negative 3 here. Let me just fix it real quick. And then negative 3 and negative 17. That makes it a, sorry about that mistake, negative 20. 3 times a negative 20 is a negative 60. And now it should work. And I think 15 will work because when we look at 60, we're going to divide that by 15. 15 and 4. So we need a negative 15 and a positive 4. Now, I knew I made a mistake, and we learn from our mistakes too. How did I know that I made a mistake somewhere? And to go back and look. I couldn't find my factors, right? If you can't find your factors and you sit here for a couple of minutes looking at it and you just cannot find the factors, go back and make sure that you didn't make a mistake. And what I accidentally did was I saw this 9 here, and for some reason, instead of writing down a negative 3, what did I do? I wrote down a negative 9, which made it not work. Right? I found all the factors. It wouldn't work. So then I went back and I saw, okay, let's see if we made a mistake. And I found my mistake. And now we found out that it will factor. Okay? We have that 3 in front. So what do we need to now do? We need to break that down because that's a 3 into our 2 separate parts. In the middle for that 11. And we're going to factor it by grouping. So what can I group together on the first 2? Well, it looks like I can factor out a 3x, and that leaves you with an x minus 5. These have a 4 in common, and again, we know we're doing it correctly because that leaves you with an x, which matches, and negative 20 divided by 4, well, that's a negative 5. We know we're on the right track because these are the same. And that is x minus 5, which is gone and gone. And what's left over? 3x plus 4, and that equals 0. Now we've done all the hard work. We have it set to 0. It has been refactored. Now we can get our 2 solutions. So x minus 5 equals 0. Moving that 5 over, one solution is x equals 5. The other one is 3x plus 4 equals 0. So 3x equals negative 4. So x equals now negative 4 thirds. Here's my two solutions. Okay, let's look at one more of these. And then we'll move on to the next section. Let's look now at 55. And let's see how we would approach question 55. And this one is going to be similar to question 14 in your homework. So this one is going to be like question 14. And these are problems that you're going to see in college algebra. This is something that you would use in college algebra. In college algebra, there's probably more to it, but this would be part of it. This one makes you think a bit. And what we've got is we've got 2x minus 3 quantity squared equals 16 x squared. Now, there are two different ways of working with this question. One way would be to look at it as a quantity squared here, take it, FOIL it out, move the 16x squared over, and then work with that. There is an easier way. Let's move that 16x squared over and see what we now have. Well, when I move that 16x squared over, that leaves you then with this. And we have looked at a lot of these in our 5.3 and 5.4 homework when we did these. What did we notice about this? Well, that's squared, okay? And what do we know about a minus 16x squared? That's also a square, right? So we know that 2x minus 3 quantity squared is 2x minus 3. 2x minus 3, because it's quantity squared. And we know that 6, well, we'll make it positive here, 16x squared, let me get rid of the sign completely, factors into 4x and what? 4x. So how is this going to factor? Well, it is a difference of squares. That's the way we're looking at it. This breaks down into 2x minus 3, 2x minus 3, and that's 16x squared. Well, that was 4x and 4x, right? That's the way we looked at it. Because this is a difference of squares here. 16 is a perfect square. Now, combine it together a little bit before we finish it. So putting this together here, we have a 4x and a 2x. Well, that makes it a 6x minus 3. And the other one, we have a 2x and a minus 4x. Well, that leaves you with a minus 2x and a minus 3. And that now equals 0. We could factor a 3 out of here, but there's really no need to because we've gotten it down to our parentheses. So let's see what we have for our solutions. Well, what do we have here? We've got 6x minus 3 equals 0. So 6x equals 3. Dividing out, 6x equals 1/2. Right? So we divided by that 6. We reduced it down, and that gave you the half there. What about the other one? What's the other one? Well, the other one is a minus 2x minus 3 equals 0. So add that 3. And you can write down the plus 3 if you want to. You don't have to. But if it helps, you can do that. So now we've got a minus 2x equals a positive 3. We'll divide by our negative 2. And there's our second solution. So x equals also a negative 3/2. And again, that is almost identical to question number 14 in your homework. That should now give you the tools that you need to completely finish 5-5. Now we're going to move on, and we're going to look at 6-1 and 2. And we're going to be talking about rational functions. And 6-1 and 2, we're going to be learning how to reduce these down, how to find the domain, multiply and divide today. Next class period, we'll look at addition and subtraction. So we're going to be looking at, today, 6.1 and 6.2. These are going to be rational functions, or expressions. And we'll probably just label it rational expressions. But these can also be functions. Rational expressions are functions. And what these are is these are fractions. So these are going to be fractions here. Now what we're going to first learn about is we're going to learn about the domain. So we're going to learn how to find the domain. And you do this a lot in college algebra. So in college algebra, you find the domain a lot. And when we find the domain, that means we find the possible values of x. So possible values of the variable x. And that means no division by 0. Because we cannot take a number and divide it by 0. So we have to first figure out what numbers are possible solutions. What numbers can exist. And we do that by setting our denominator to 0. So we're going to find the domain for these. We'll start off with an easier one. Then we'll look at some that require us to factor. So this is what I'm giving you here. Are we finished? So this is what we're looking at, and we're going to be finding the domain. Now again, when we talk about the domain, we want to find the division by 0 and take it out. So what we do to find the domain is we set the denominator to 0. And this is something that we do a lot of in college algebra. So first thing we would do is we set that denominator to 0. So denominator is the bottom half of this fraction. So x minus 3 equals 0. When we move it over, we get x equals 3. Okay? Now, why is that important? Well, if I plug the 3 here, what do I have? 3 minus 3, and that's a 0 in the denominator. Can you take a number and divide it by 0? No. So that number is the number that does not work. Now, how do we write our solution? Okay, so this is the number that doesn't work. That's the number that is not in the domain. How do we write our answer? Well, we write it in interval notation like this. Your domain is negative infinity to positive 3 union, positive 3 to infinity. What that is saying is every number will work as a possible solution except for what? Except for 3. Let's do another one. We'll do 3 of these. That one only had one answer. We're going to find the domain of this one. And this one's going to have multiple answers. So how about we have 8x plus 7 over, how about we use x squared minus 5x. Now, what are we doing? And this is going to be equal to f of x. Whenever it says f of x, they're going to want you to find the domain on these. What we're going to be looking at is we're going to be looking at the denominator. We do not care at all about the numerator. When we find the domain, the top half of this fraction is irrelevant. All we are looking at is the denominator. So we set the denominator to 0. And when I set this to 0, I get x squared minus 5x equals 0. And I can solve this by factoring. So I can factor an x out, and that leaves you with an x minus 5 left over. Now we are going to get 2 solutions, because we have x equals 0 from the front, because we factored an x out. And we also have x minus 5 equals 0, so x equals 5, right? X equals 0. Watch your signs, x equals 5 there. Now, how do we write our solution? These are the numbers that do not work. So we write our solution as this. Our domain is going to be negative infinity to the smaller number, which is 0. Then we use a u for union. 0 to the next number, which is 5. And then we use a u for union. 5 to positive infinity. And that is saying in interval notation that all numbers work as possible solutions except for what? Except for 0, possible values you can plug in, all work except for 0 and 5. Right? Every other number works. 0 and 5 don't, because they give you division by 0. One more, and then we'll talk about how to reduce these down. Again, we're going to be finding the domain. Now, how is this one different from the others? Well, in all of the others that we looked at, the 2 before, we had an x in the denominator, didn't we? This one, this has no x in the denominator. If you have no x in the denominator, you can never have division by 0, because there's no way that I can make this 0, right? Because there's no x with it. There's no x in the denominator, so that means your domain is all real numbers or negative to positive infinity, because you can plug in any number that you want and get out an answer. Never can you have division by 0, because that's just the whole number 5. And this is going to be like the first question in your homework. Now, we've seen how to find the domain, and that's something you'll work with more in college algebra. Now let's learn how to reduce. When we reduce these fractions down, we have to factor. I'm going to pick a couple of these from our textbook, just so it's a little bit easier to work with. Okay, so let me get get back to the 6-1 here. We'll look at a couple of these. These are going to be rational expressions that we can factor and reduce down. So I'll just pick a few. They're all done pretty much the same. Let's look at, in case you want to follow along, let's look on page 394. We're going to look now at, how about question number 43. Now, our goal is going to make this as small as possible. And we do that by factoring. So our goal is going to be breaking this down. And we want to write this in lowest terms. That's what the directions are. These are going to be right in the lowest terms. We're going to be simplifying here. Well, we do that by factoring. So let's factor out from the numerator, and let's factor out from the denominator. In the numerator, we do them separately. Okay, so in the numerator, if you want to, you can write them over to the side. The numerator is 2t plus 6, so I can factor it at 2, and that's going to leave you with a t plus 3. Is everyone okay with that? So we did the numerator. Greatest common factor. That's all we can do is factor out that 2. Now, what about the denominator? In this denominator, we have t squared minus 9. And we know that t squared minus 9, well, 9 is a perfect square, so that's going to factor into t plus 3, t minus 3, isn't it? Now, why is that important? Well, that is important because what can we now do? We can look at our groupings, our factors here, and we can cancel them out, just like reducing down a fraction. So what can we do? Well, we have a t plus 3 and a t plus 3 down below, so those can go away. And what does that now reduce down into? What's left over? In the numerator, the top half, we have a 2. And what's down below in the denominator? T minus 3. And that's as far as you can go. And so we factored it, and we reduced it. Question 46. We're going to look now at question 46. There are a couple like these as well. These are trinomials we're going to factor. The last one was a greatest common factor and a difference of squares. Well, this one is trinomials. And again, we're going to try to write this in the lowest terms. That's going to be our goal, is write in the lowest terms. And we're going to work with the numerator. And the numerator, we have y squared minus 5y minus 14. So we need to factor this, so we put our 1 in front. And by the way, these should factor nicely. Everything should factor out nicely. 1 times a negative 14, well, that's a negative 14. Sign in the middle is negative, so that means larger number is negative, smaller number is positive. Well, 14, there's only 2 possible choices, 2 and 7, right? So how about we use a negative 7, positive 2. That works because those go together to give you the 5 in the middle, right? Pretty simple, pretty easy there. No factor by groupings, so that's just going to factor down into y minus 7, y plus 2. Let's now look at the denominator. And it will factor out quickly as well. Y squared plus y minus 2. Well, we put the 1 in front. 1 times a minus 2, well, that is your negative 2. Negative, so we know one number is positive, one number is negative. Sign in the middle is positive. And there's only two factors of 2, 2 and 1. So this should factor out, again, very simply, very easily. How about we use a positive 2 and we use a negative 1? Those work because they multiply together to give you the negative 2 in the box, and these subtract from each other to give you the 1 in the middle. So that factors into y plus 2, y minus 1. So we factored. Now what can we do? Well, we factored these down, and so we know that that y plus 2 and that y plus 2, well, those can cancel. And what's left over now? Y minus 7 over y minus 1. Let's do another one. Let's look at multiplication. And multiplication is going to work just like what we've done before. We are going to have to factor in some cases. So let's look at some multiplication, and then we'll look at division. But we are going to have to factor or work with these groupings. So question 73. P squared minus 25 over 4p times 2 over 5 minus p. This one may require us to do a little bit of thinking to get it all to work out the way it needs to be. The first thing I would notice is I would look at this and I would see that we have in this first fraction, right, we have a p squared minus 25. And we know that 25 is a perfect square of what? 5. So this will factor right here as p plus 5. Okay. Let me write it in the right order. P minus 5. So p plus 5, p minus 5, and then we've got a 4p. And then we're going to be multiplying that by a 2. Now, let's look at this here. And let's compare it to that. I have a 5 minus p, and it is fairly close to a p minus 5. Let's see if we can turn this into that by factor. So we're going to start with the 5 minus p. And this one over here is what we're looking at, right? Because this is positive and negative. It's a p and it's a 5. So let's see if we can make this look like that. Well, first off, let's write it in the correct order. So let's put this, remember this is a plus here with that 5. So let's put this as a minus p plus 5. So we're fairly close to here. What can we factor out of this, though? When we look at this, well, this has a negative. So I'm going to factor out a negative. And that's going to then leave me with the p minus 5, isn't it? Because negative came out of there. That switched your signs. Is everyone okay with that? You want to make sure that the pieces look the same, the parentheses look the same, so that they can be canceled out. Now we should see it, because now we can see what we can do. Well, that p minus 5 and p minus 5, those are gone. Then we can look at the 2 and the 4. Just like any other fraction, we can reduce. So that's a 1 and that's a 2. Now what's left over? This went away, but this negative is still here. So that's like a negative 1. So what do we have left? Let's write out what's left over. And what didn't get crossed off? P plus 5, right? Nothing canceled with that, so that stays there. That is gone. That is gone with that 2 down below. Okay, so what is left over? I didn't mean to look so confusing here. But what's left over is we have a negative from here, okay? And then we have a 2p. And you can write this a variety of different ways. You never want to leave a negative in the denominator. So you could bring this up to the top, and you could write that as minus parentheses p plus 5 over 2p. Or you could write it as minus p minus 5. Same thing. But all I did there was I just simply chose to bring that negative up to the top. Let's do one more. And then we'll look at division. So let's look at, and this is going to be a more lengthier one. Let's look at question 86. This one's actually easier once you do all the factoring. But the factoring should not be difficult in this section. It should be pretty easy. Pretty straightforward. Very, very little factor by grouping. The numbers on the trinomials are usually pretty small. So let's look at this. Go from here. It's t squared minus 2t minus 35. Okay, so we're going to have to do a lot of factoring. This is a multiplication dot here. But all these should factor out really, really quickly. None of them are going to be difficult. We'll start up here and just work our way across and down. So t squared minus 49. Perfect square. T plus 7. T minus 7. So easy enough. No problems there. What about t squared plus 4t minus 21? Well, first times the last is a minus 21. We know sign in the middle is positive, so positive and negative. And there's not very many factors of 21. About the only one that we have is 7 and 3. Okay? So we're going to use a positive 7 and a negative 3 here. And that is then t plus 7, t minus 3. What about the next piece? Well, factor again. T squared plus 8t plus 15. 15 goes in the box. Sign in the middle is positive. Not very many factors of 15. 5 and 3. That's about all we can do to get 8. So t plus 5. T plus 3. And the last piece, it factors out quickly and easily as well. T squared minus 2t minus 35. That's a minus 35. Sign in the middle is negative. Not very many factors in 35, just 5 and 7. So we're going to use a minus 7, positive 5. That factors into t minus 7. T plus 5. Now, all of it's done. We can now work with it however we want. We can cancel on the diagonals. We can cancel up and down. So let's just try to cancel out as much as we can at the beginning. So t plus 7, gone. T minus 7, gone. T plus 5, gone. Okay, so after all of that work, what is left over? what is left over is a t plus 3 and a t minus 3. That's it. If nothing factors, nothing reduces. I cannot cancel out the t's. Why not? Can you factor? No. If you cannot factor, you cannot reduce. That's the main thing you need to remember. You can't factor, you can't reduce. That was multiplication. Now let's talk about division quickly. So this will be our last question here. So I'll go ahead and pass out the sign-in sheet. Pass out the sign-in sheet, and this is going to be our last question. Now we need to talk about division and how division works. Well, division, we've got to turn it into multiplication. So let's look at a fairly simple one. How about question 83? Same directions. When we divide, though, we have to turn it into multiplication. So we're going to turn this division, okay, into multiplication. And that means we simply take our second fraction and flip it over before we do anything else. So we're looking at 83. So we have 12x. Oh, sorry, not 83. That's multiplication. Sorry about that. Let's look at 82. My mistake. 82. This is division. I was looking at the wrong one. Question 82. So we've got k squared minus 4 over 3k squared divided by 2 minus k over 11k. Now, notice we have division. So when we have division, we need to make it multiplication. And how do we do that? Well, whenever we divide, it's the same thing as multiplying by the inverse. So I can take this and I can rewrite this as k squared minus 4 over 3k squared. And then I'm going to make it multiplication. And I'm going to flip this fraction over. And that's going to make it on 11k over 2 minus k. So the second fraction gets flipped over. Now we factor and we simplify. So let's see what we can do. This one's simple. K squared minus 4. 4 is a perfect square of 2. So that is k plus 2. K minus 2. And we've got a 3k squared there, which we'll deal with in a moment. Then we have 11k. Now, 2 minus k. So we've got 2 minus k. Well, we want this. We want k minus 2. How do we make this look like that? Well, we begin by rewriting it in the correct order. So that's minus k plus 2. The variable always goes first. Then we can factor out a minus. Now we have it, right? See what I did. We wrote it with the variable first, and if it ever begins with a negative, you factor it out. And why did I do that? Well, I did that, so I can now factor. So what's going to cancel out? K minus 2. K minus 2 is gone. What else can happen here? K and k squared, that leaves you with a k. So let's write out what we have left, and then we'll deal with what's left over. So what's left over here on the top, we have an 11. Oh, thank you, Amber. And did I give you the new packet yet? No. So what we have is we have the 11 that's left over, And then we have a k plus 2. That's there. And we still have that 3 down below. And a k. And don't forget about the negative. We want to go ahead and bring this negative up to the top, because you never want to leave a negative down below. So bring it up to the top. And we can now rewrite this as minus 11 times k plus 2 over 3k. Or you could write it as, same thing, distribute it through. I'll take either one. You could also write this as a minus 11k minus 22 over 3k. They are the same, and I will take either one. We can now look at our homework. And so for your homework, you should be able to do 5, 5. Those are equations. You should be able to do them all. So you should be able to do all of 5, 5. Now, 6, 1 and 6, 2, we should be able to do most of it. So 6, 1 through 6 and 6, 2, you should be able to do now, I believe, 1 through 11. Well, actually, yeah, 1 through 11. So 6.1 and 6.2, you should be able to do 1 through 11. Well, that's it for today. So I will see everyone then on Thursday. And Thursday we're going to finish up. We talk about variation. So this is 3-7. We're going to be talking about